as there are more renewable energy connected to the grid. How would the grid network be evolved in the future? In the current grid network, there are many different DC sources. For example, the PV photovoltaic solar cell, small wind turbine, fuel cell, battery, so they are all DC sources. In order to connect these DC sources to the AC network, we need to use a converter. So this is what you have learned in the sessions about solar power system. The PV panel needs to be converted back to AC in order to connect it to the utilities. This is the typical connections. The DC source from the solar panel will be connected to a controller, and then it can connect it to different phases in the AC network. And the advantages of connecting to the grid network is that by connecting to the grid network, the transmission loss can be reduced, and also you can make sure that the supply of electricity is stable and reliable. Because even though your solar supply is not available, the power supply company can still provide power to back up the supply. However, most of our devices using nowadays are DC operated. Like in your mobile phone, your laptop, even your TV, you need to use a DC power supply or an adapter to convert AC to DC. So every household will have a lot of those electric waste. And also, these conversions of AC to DC will also lose some energies. And you may question, why not we use DC directly? Why we use AC? One of the reasons is because long times ago, we make use of the magnetic coil to generate AC power, and this is still being used nowadays in most of the generator. So in the fossil fuel power plant, in the nuclear power plant, whenever you rotate the generator, so this AC current will be generated. And therefore, in most of the power distribution system, we are still using AC. And AC do have an advantages of being easily step up and step down the voltage by using a transformer. However, the age of DC currents is now emerging. Solar panel, LED lighting, computer, or semiconductor electronics, they are all running in DC. Is it possible for us to connect all those devices, including the source and loading, using DC? So this diagram is quite complicated, and why not we just standardize the voltage of a DC, and all of these devices can follow these standards. Then we don't need to do this conversion, and remember, in each of those conversions, there will be some loss. This is the current distributions of an AC power network. So the AC grid from the power supply company will then be connected to the riser and rise to different floor in this building, and we need an AC to DC converter to connect it to the DC loading. So in this diagram, those highlighted in red color are AC current, and those in blue color is DC. So any DC supply, like the PV panel, has to convert it to 220 volts before it can connect it to this AC network. And for the fuel cell or battery backup, it still need to convert from this DC to AC before it can be connected to this AC grid. But some engineers and scientists already proposed that why not we install DC power distribution network in a building instead of an AC, so that the storage, fuel cell, wind, and PV all running in DC can be connected together to supply the power for those DC operated facilities. For example, the LED lighting or some DC loading. But at the same time, we can also connect it with the AC loading from the mains with a single centralized AC to DC converter. There are some proposed standards such as using 400 volts, using 2-wire or 3-wire, and connect it all the way inside the building using DC power cable. And there are still some devices using AC, but this time we convert AC to DC and then feed to this DC centralized distribution network. So some analysis have been done, Compare with the 220 volt AC with a 400 volt DC power distribution system from the transmission side to the consumer side throughout the distribution network. So the loss across these transmissions for AC is finally 2.4% loss, but for DC 400 volt is 0.74%. Okay. And this diagram showed us that the higher the power rating, then this saving will be more significant. When the power rating is high, then the conversion efficiency for DC to DC is higher. In general, no matter in which power rating sections, and in general, no matter in which power rating segment, DC to DC conversion is always higher than AC to DC conversions or DC to AC conversion. So we also studied the efficiency improvement of this DC distribution network, and the efficiency improvement in terms of different sector is as follows. For residential is about 17%, for commercial is 9%, and then for school is about 18%. And one of the school in Hong Kong, in Ma Wan, is also installed with the PV system, and then the distribution system in this building is a DC network. So we have also conducted an analysis in this school if they change this distribution network into DC, and the overall saving in a year could be around 62,000 Hong Kong dollars. The merits of a DC distribution system is as follows. You can save the material costs and capital equipment. You don't need those transformer and soft iron to do step up and step down the power. And also you can improve the power quality. You don't need to worry about the harmonics and the phase angle problem. And the total system efficiencies can therefore be improved. And more importantly is that it can interface with the renewable energy, so that you can make use of different types of renewable energy and connect it to the DC's grid network more easily. However, there is still no well-accepted standard for the DC distribution network. There is no standard on the voltage, the connectors, and the power design, and so on. Therefore, we rely on you. Let's work together to develop a better DC distribution network to empower renewable energies for our future. Thank you.